Okay, another example. Same equation we started with, and we remember solution is x equals 3, y equals 2. We solve this system by what we call elimination. And it turns out that in this case the system is very easy to solve by elimination. Notice if we add the two equations, over here we get 6x. Here we get no y. And here we get 18. So we have 6x equals 18. So x is 18 divided by 6, which is 3. Then if we plug 3 into either of these equations, well, 3 times 3 is 9, so we have 2x plus 9 equals 12. Okay? And it doesn't work at all. So what did I do wrong? I think maybe instead of 9 it should have been 6. Yeah, doesn't matter. We'll see. Okay? Anyhow, the point is, if you add these two equations, you eliminate y. And you just have an equation in x, which you can solve. That gives you a value of y that you can plug into either equation, so you can solve for x. Now, that was too easy, but sometimes it comes out that easy. You know, the y's just happen to have equal and opposite coefficients. To eliminate x, I'll say y is too easy. So we're going to eliminate x. What we do is we take the first equation, which I'll indicate by a circled 1, and we multiply it by -2. Now you see why I would do that in a minute. If we multiply this first equation by -2, -2 times 2x gives us -4x. -2 times 3y gives us -6y. -2 times 12 gives us -24. So if I multiply this first equation by -2, I get this. If I then write the second equation, I'll just put a 2 down here, and I'm not doing anything to the second equation. I'm just saying, okay, that's 4x minus 3y equals 6. Okay? Then I add the two equations. Well, -4x and 4x gives me 0. So x is eliminated. -6y and -3y gives me -9y. -24 and 6 gives me -18. So I get y equals 2. Okay? So I've solved for y.
Can you tell me, why did you pick 2 multiplying by -2 in the first place?
So these things that add up to 0.
Ah, okay, gotcha.
So, yeah, let's go back. When I look at these two equations, I see that. I ask myself, what can I multiply one equation by to make the equation match up so x goes away? Now sometimes you have to use two different numbers, but yeah, the videos will cover that for you. So I'm giving you the basic principle, and that step will give you no trouble, I think. Okay, but let's see where this ends up. So now we've got y equals 2. So what I do is I'll use a different color to do this. Okay, I'm going to take y equals 2, and I'm going to bring it all the way up here and plug it into the first equation. Okay, which gives me an equation that I can now write here as two x plus 3 multiplied by the 2 that I got for y, so that 2x plus 6 is 12. And it's very quick, 2x then equals 6 and x equals 3. And now I've got my solution. So I take this and this, x equals 3, y equals 2. That's elimination. Now we're short on time, so I'm not going to... I would ordinarily do another example where you got to multiply this equation by one number and this by another. But you'll see that, and I don't think it's going to give you any trouble at all. Okay, one other way of solution. One other means of solution. We're solving the same system by substitution. So we have 2x plus 3y equals 12, 4x minus 3y equals 6. We solve the first equation for y. Instead of writing the first equation, I'm going to write 1 with a circle over it. Solve equation 1 for y. Now you've got to subtract 2x from both sides and divide by 3, but you're not going to have any trouble with that step. You got y equals negative 2/3 x plus 12. We plug that into the second equation. And plug what? Plug this expression for y into the second equation. So this plugs in here and gives us the equation 4x minus 3 times y equals 6. But y is negative 2/3 x plus 12. Hopefully that's legible. And that's not right. Shouldn't be 12. Just looking at the next step, I know that's not going to work. When I solved for y, I didn't do it right. I got my negative 2/3, and then I stopped thinking and just wrote down what I had. Not a good way to solve. Plus, okay, well actually, it's minus. Okay, solving this for y, we're going to, it's not negative either. Wait a minute, we solved the first equation. Okay, I'm back in the real world again. we're subtracting the 2x from both sides and then dividing by 3. When you divide the 12 by 3, you're going to get plus 4. Okay, so we take the negative 2/3 x plus 4 and plug it in here for y. And now notice that we have an equation for just x. We don't have any more y's. Well, we again get 4x minus 2x minus 12 equals 6. Because negative 3 times negative 2/3 gives us 2. And negative 3 times 4 gives us negative 12. Well, that gives us then 2x I've got trouble here. This has to work. Negative 3 times negative 2/3 is plus 2, not negative 2. Right? I think I even said it right, I just didn't write it down correctly. Then I believed what I'd written down. So, just illustrating why you got to be careful, pretending to make mistakes, you know how it is. Okay. Sorry, 6x, and we get 18, so that x equals 3. And now, we've got x equals 3, and we can plug that into the first equation, and that gives us two times 3 plus 3y equals 12. Okay, with the 3 that we got there, indicate that by the color, and that's we got y equals 2, and now we put this together with this, and we get x equals 3, y equals 2. Okay. Well, we actually got through quite a bit here. This is a pretty good introduction, I think, to your section on simultaneous equations, 2 equations and 2 unknowns. Now you have to look forward late next week to 3 equations and 3 unknowns, which is harder to graph because you'd have to graph it in 3 dimensions, so you don't graph that. You just do it by elimination or substitution. If they're linear equations, we usually use elimination. And if they're not linear equations, we have to use substitution. Okay, so we're going to do 3 linear equations mostly and 3 unknowns, which uses many of the same methods here. We just do a little more elimination. And then the following assignment after that, we solve by substitution with linear equations that aren't linear. Everything builds on the solution of 2 linear equations and 2 unknowns.